general solution or particular solution. Now, the second method is homogeneous differential equation. So, first we should understand what is a homogeneous differential equation. Let us consider functions in x and y. Let us consider functions in x and y such that now I will write some functions. You can see f1 of xy is equal to y square plus 2xy. We will take another function f2 of xy is equal to 2x minus 3y. Let us take one more function which is f3 of xy is equal to cos of y by x. Next, let us take f4 of xy sin x plus cos y, sin x plus cos y. Now, let us consider this four functions f1, f2, f3, f4. So, what is homogeneous? Let us see. For finding homogeneous function, we should find out replace x by lambda x, where lambda is a non-zero constant, x by lambda x, y by lambda y. Replace x by lambda x and y by lambda y, where lambda is a non-zero constant. Now, let me do it for one function here, f of lambda x, lambda y I will calculate, because x should be replaced by lambda x, y is replaced by lambda y. Now, what happens here? Y square is there. Now, this will become lambda square y square. Next, plus 2 into lambda x into lambda y. You understand this? We are replacing lambda x, x by lambda x and y by lambda y, where lambda is a non-zero constant. Now, here I can write this as lambda square into y plus 2xy, lambda square into y plus 2xy. So, this is lambda square into what is y square plus 2xy, which is nothing but f1 of xy. So, we started with f1 of lambda x comma lambda y, which we got it as lambda square into f1 of xy. Similarly, f2 lambda x lambda y, I am taking the second function. What will be this? This will be lambda into 2x minus y, or lambda into f2 of xy, lambda into f2 of xy. Now, let us take f3 lambda x lambda y. Now, cos of y by x, cos of lambda y by lambda x, this is equal to lambda power 0 into cos of y by x. So, that is lambda power 0 into f3 of xy, f3 of xy. Now, you can see we are replacing in the given function x by lambda x, y by lambda x. In this first function we got lambda square into f1 of xy, the second function lambda into f2 of xy. That is, here we can consider this as lambda 1, lambda power 1. The third question, f3 of lambda x lambda y is equal to lambda power 0 f3 of xy. Now, let us take the last one, f4 of xy. What is f4 of xy? Now, this is sin of lambda x plus cos of lambda y. So, this cannot be written as lambda power n into f4 of xy. See, this cannot be written in this form. The fourth cannot be written in this form. Now, a function f of xy is said to be a homogeneous function if it can be f1 of lambda x, f of lambda x lambda y is equal to lambda power n into f of xy. So, that function is called homogeneous function, or simply for you to understand, you can see the terms, all these terms should have the same power. Here y has got 2, here x1, y1 both put together it is 2. Here x has got 1 power, y is also power 1, so it is homogeneous. Here also it is 0 power, y and x. So, 0 power is there. So, lambda power 0, but here we cannot say that is homogeneous. Sin x plus cos y, we cannot, the fourth equation we cannot, fourth function we cannot say that it's a homogeneous function. So, what is the definition for a homogeneous function? Let us take that. A function f of xy is said to be homogeneous, if f of lambda x lambda y is equal to lambda power n into f of xy, where lambda is a non-zero constant. So, what is the definition of homogeneous function? A function f of xy is said to be homogeneous if f of lambda x lambda y is equal to, we can write it in the form of lambda power n f of xy, where lambda is a non-zero constant. So, in the first three functions f1, f2, f3, the degree of the function is 2, 1 and 0. You can see the first function the degree is 2, second function degree is 1, third function degree is 0. Fourth function is not a homogeneous function, because we cannot write this f4 of xy as lambda power n f4 of xy. We cannot write it. So, it is not a homogeneous function. Now, it should be clear for you. We will be solving the homogeneous functions. Okay. Now, we can do one more, this one. I will take f1 of xy, which is y square by y square plus 2xy, y square plus 2xy. Now, I am going to divide this by x square, you see, y square by x square. So, for this what I have to do? I have to multiply. So, I can write this y square term as x square into y square by x square plus this can be written as 2 into y by x. You see, when you multiply with x square, you will get 2xy. So, this is can be written as x square into g of y by x. It's a, this is a function of y by x, x square is taken out. So, this can be written as g of y by x. This is also y by x function. So, both the terms contain y by x. So, we can write it as g of y by x. One more method we can do it, same function f1 of xy. Let me take y square outside. We can write this as, if you take y square if you take it, it will be one plus, you can write this as 2 into x by y Is it all right? You see, check y square plus y square, if you multiply, you will get 2xy. So, this function is nothing but it is in the form of y square into h of x by y, h of x by y. So, another way of defining homogeneous function is we can do f2 of xy, f2 of xy, both we can write it. So, all the three functions we can convert it in this form. So, we can have another definition for homogeneous function, a function f of a function f of xy, a function f of xy is a homogeneous function, is a homogeneous function of degree 0 if f of xy can be written in the form of, first one is x to the power of n g of y by x, or y to the power of n h of x by y. So, either of these forms the function becomes a function f of xy is a homogeneous function of degree 0 if f of xy is equal to x power n g of y by x or y power n h of x by y. Next, we will define homogeneous differential equation. So, what is a homogeneous differential equation? Very simple. A homogeneous differential equation is one in which the function is a homogeneous function of degree 0 or degree 1, degree 2, etc. So, two methods of defining homogeneous functions. Either you can use this f of lambda x, lambda y, comma lambda y is equal to, we have to write it as lambda power something, that is power should be n, that is natural number, and then into f of x y, or we can write capital F of x y is equal to x power n g of y by x. Here the degree is 0, y power n h of x comma x by y. Either of these forms we can use for finding out a function is homogeneous function. If a differential equation contains homogeneous function, then that differential equation is called a homogeneous differential equation. Now, homogeneous differential equation, we will define homogeneous differential equation. A differential equation, a differential equation of the form, a differential equation of the form dy by dx is equal to f of xy is called a homogeneous differential equation, homogeneous differential equation if f of xy is a function, is a homogeneous function. F of xy is a homogeneous function of degree 0. So, definition for differential equation. So, we have used the second definition of homogeneous functions. A function, a differential equation dy by dx is equal to f of xy is called a homogeneous differential equation if f of xy is a homogeneous function of degree 0. So, this is this one. Now, let us take the first example, how to solve differential equation. Show that the differential equation show that the differential equation x minus y dy by dx is equal to x plus 2y is a homogeneous equation and solve it. So, two things we have to do in these problems. We have to first prove that it is a homogeneous function. So, what is the differential equation that it has been given to us? You can see dy by dx is equal to x plus 2y divided by x minus y, x plus 2y divided by x minus y. Now, take what is the function given here? F of xy is equal to x plus 2y divided by x minus y. How to prove that it is a differential homogeneous differential equation? We have to replace x by lambda x, y by lambda y. Now, calculate f of lambda x lambda y, f of lambda x lambda y. See, this is x plus, this is lambda x plus 2 lambda y, lambda x minus lambda y. So, lambda can be taken out and it gets cancelled. So, what you can write it here, x plus 2y divided by x minus y. So, lambda x plus 2 lambda y, lambda x. So, lambda if you take out, lambda gets cancelled. So, it is lambda power 0 into f of x comma y. So, f of x comma y is a homogeneous function. See, we have written, replaced lambda x by lambda x, lambda y by lambda y, then immediately we got lambda power 0 into f of x y. So, f of x y is a homogeneous function. Now, for solving this equation, keep this as 1. We have to take a substitution. What substitution that we are going to take? You see, take y is equal to Vx, or y by x is equal to V, y by x is equal to V, or y is equal to Vx. Now, differentiating this with respect to x, differentiating with respect to x. So, this side we get dy by dx, here V into 1 plus x into dV by dx, x into dV by dx. Now, we have to substitute, take this as equation 2 using 2 in 1, using 2 in 1. So, what is dy by dx here? V plus x into dV by dx is equal to, now we have to substitute for x plus 2y. Suppose if you divide it by x, here it becomes 1 minus y by x, here 1 plus 2 into y by x. Y by x is V. So, we can write this as 1 plus 2v divided by 1 minus v, 1 plus 2v divided by 1 minus v. So, this equation we let us simplify, x into dv by dx is equal to, x into dv by dx is equal to 1 plus 2v divided by 1 minus v minus v. So, this v we have taken to the other side. Now, simplify this. 1 plus 2v minus v plus v square divided by 1 minus. Now, this is v square plus here v we get plus 1 divided by 1 minus v. This is x into dv by dx. Now, the previous method is variable separation. Now, the variables are x and v here. So, we can separate the variables. How to separate the variables? Bring the variables here. 1 minus v by v square plus v plus 1 into dv is equal to dx by x. Now, I can write this as 1 instead of 1 minus v, we can write it as v minus 1 and I will take minus sign here. So, v minus 1 divided by v square plus v plus 1 dv is equal to, so now variable separable is over. Now, we have to integrate this. How to integrate? Let us see. Integrating integral of 1 minus v divided by v square plus v plus 1 dv is equal to minus integral of dx by x plus, you can write C1 constant, some constant we have taken, that you can write it as C1. How to integrate this? Let me say, give you some idea about how to integrate. Here it is 1 minus v, that is v minus 1 we have written already. It is v minus 1. Now, I will multiply and divide by 2. For this, you can write this as 2v minus 1, 2v plus 1 minus 3 divided by v square plus v plus 1 dv is equal to minus integral of dx by x plus C1. Now, what is the integration for this? You can see, you can have two integrals here, 2v plus 1 divided by v square plus v plus 1 dv minus 3 into 3 by 2 into 1 dv by v square plus v plus 1 is equal to minus dx by x plus C1. Now, this substitution method will work. Here I have multiplied by and divided by 2, we get 2v minus 2. In that 2v plus 1 minus 3 we should write it. So, denominator is the substitution here, numerator becomes dt. Now, this one how will you integrate? 1 by 2 into 2v plus 1 v square plus v plus 1 dv minus 3 by 2 into, see here we have to do completing square, v square plus, it is a quadratic equation, completing square. What is the completing square? See, we need 1 by 4 for this. 1 by 4, that is v plus 1 by 2 whole square plus root 3 by 2 whole square is equal to minus dx by x plus C1. Now, we are ready for integration. This is a v, see here you get v square plus v plus 1 by 4, here 3 by 4, 1 by 4 plus 3 by 4 is equal to 1. So, this integral, how to integrate? This integral we can easily integrate 1 by 2 log v square plus v plus 1 minus 3 by 2 into, this is a square plus x square form, 1 by a tan inverse of x by a, 1 by a is root 3 by 2 tan inverse of v plus 1 by 2 divided by root 3 by 2 is equal to minus log mod x plus c1. So our integration is over. Now we have to substitute for v, we have to substitute y by x. Y by x we have to substitute. V is equal to y by x. 1 by 2 into log y square by x square plus y by x plus 1. Here you see we get root 3. Here we get root 3 there. Tan inverse of this is 2v plus 1. This is 2v plus 1 by root 3. That is 2 into y by x plus 1 divided by root 3 is equal to minus log mod x plus c1. Now, if we simplify this, it is almost over. That is, the differential equation is, so here it is x square. So, x square is there, log x square plus xy plus y square divided by x square minus, we can multiply this by 2. This 2 if you want to remove, we have to multiply by 2 here. Now 2 root 3 tan inverse of here 2y plus x divided by root 3x is equal to minus log mod x plus c1. Now, further simplification is possible. You can see it is a worked out example. You can see it in the book and simplify it. This is the differential equation. We can simplify further also. Here x square can be removed. That is a minus log x square. If you remove minus 2 log x, it will become minus log x square. Minus log x square is 2 log mod x. So you can take it to the other side. It will become log. See here, this will be log of x square plus xy plus y square. I am taking this as minus log x square, which is minus 2 log x. Minus 2 log x, when it goes to this side, it will be plus log x, it will be. So minus root 3, and here also this is 2, we have multiplied it by 2, so it will become 2c1, because this 2 we have removed. So here you have to multiply by 2, here also you have to multiply by 2, here also you have to multiply by 2. So 2 into root 3 tan inverse of 2y plus x divided by root 3x. Now minus 2 log x minus 2 log x cancels. Now this can be written as c, where 2c1 is equal to c. So this is the final answer for the differential equation, homogeneous differential equation. You can see homogeneous differential equation. First, what is the steps I will explain to you. Again, y is equal to vx you have to take, and using 2 in 1, we change y to v. So x into dv by dx is equal to, in terms of v we get, simplify it and variable separable. You can do variable separable method, and then integration is all these steps. So only integration and back substitution of v is equal to y by x. So each problem will be little bit lengthy problems, because integration they have given like that. So tough integrals are given here. Whenever we do homogeneous equations, that is the problem. Integration we should be careful. and we should be thorough with integration, then we will be able to get the necessary answers. Okay. Show that the differential equation x into cos y by x is equal to dy by dx is equal to y into cos y by x plus x is a differential homogeneous, and solve it. First we have to say that it is a homogeneous equation, and then we have to start solving. How will you solve? We have to use the substitution, put y is equal to Vx. Now, the given differential equation is dy by dx is equal to y into cos y by x plus x divided by x into cos y by x. So, how will you prove that it is a equation which is what is f of x y? F of x y is this, that is f of lambda x, f of x y is y into cos of y by x plus x divided by x into cos of y by x. So, this is the f of x y. Now, we have to find out f of lambda x lambda y, lambda x lambda y. This is lambda x. If you put lambda x lambda y, you will get only y by x plus this is lambda y lambda x divided by lambda x cos. So, here also lambda y, here also lambda x. So, lambda lambda cancels, so y by x will be there. Now, what is this? Lambda cancels, you can get lambda power 0 y into cos of y by x plus x divided by x into cos of y by x. So, this is nothing but lambda 0 into f of x y. So, we have written f of lambda x comma lambda y as lambda power 0 f of x comma y. Therefore, f of x y is homogeneous. Now, let us keep this equation as 1. So, we have to proceed to solve. First part is show that it is a homogeneous homogeneous function we have taken. So, it is a homogeneous differential equation. Now, we get put y is equal to Vx, put y is equal to Vx. So, differentiating with respect to x, what we get here, dy by dx is equal to v plus x into dv by dx. Why we are doing it? We are coming to variable separable form. Once we take the substitution, the differential equation will become variable separable. So, using 2 in 1, v plus x dv by dx, because for dy by dx we have substituted this. Now, for here you can write this as y by x, y is equal to what? Vx, Vx into cos of y by x plus x divided by here x into cos of y by x. What is cos of y by x? Y by x is v. So, this is v. Now, this becomes x cancels, v cos v plus 1 divided by cos v. So, we have substituted y is equal to Vx, x cancels, and we get v cos v plus 1 divided by cos v. Now, x into dv by dx is equal to v cos v plus 1 divided by cos v minus v. So, this can be written simplified as v cos v plus 1 minus v cos v divided by cos V. Now, x into dV by dx is equal to 1 by cos V. See, once we substitute y is equal to Vx, the differential equation gets converted into variable separable form. Now, cos V dV is equal to dx by x. So, integrating integral cos V dV is equal to integral dx by x plus c. Now, what is the integration of cos V? That is sin V is equal to log mod x plus c. So, very simple integration this is. Now, we can write sin of y by x is equal to log mod x plus c is the solution, is the general solution. So, this is the general solution for the differential equation. What is this? dy by dx is equal to y cos y by x plus x divided by x into cos y by x. So, you can see first we have proved that it is homogeneous, and then taking put y is equal to Vx in the equation, that we get dy by dx is equal to V plus x dV by dx. Substitute in 1 and simplify, we directly arrive at x into dV by dx is equal to 1 by cos V. Then variable separable and integration, the steps are like this. So, sin of y by x is equal to log mod x plus c is the general solution. We see the third question. So far 2 questions we did general solution. Now we have to do particular solution. So, show that the differential equation 2y e power x by y dx plus y minus 2x e power x by y dy is equal to 0 is homogeneous, and find its particular solution given that x is equal to 0, y is equal to 1. So, I will write the, see, you can see here x by y. In the previous problem, so y by x was there. Now it is x by y. So, we have to change the substitution. This is the differential equation of the form h of x by y. You can see homogeneous functions. How I have defined the 2 types of definitions. One is f of x y is equal to g x power n into g of y by x, or y power n into h of x by y. So, this is a second method, that is y power n into h of x by y. So, x by y we have to substitution we have to take. Now, for this 2y e power x y dy is equal to 2x e power x by y minus y into dy. Now, take this as dx by dy. Understand this point here, dx by dy, not dy by dx. Now, 2x e power x by y minus y divided by 2y e power x by y. So, here f of x comma y is equal to, now I can write this as, you can see 2 into x by y divided by y e power x by y minus 1 divided by 2 into y we have divided. So, it is e power x by y. So, this is of the form lambda power, this is of the form we can write y power 0 into f of x by y, y power 0 into f of x by y form it is that. This is also x by y, x by y, x by y. So, is a, hence it is a homogeneous differential equation. Differential equation. We can put lambda x, lambda y also. Just I have changed for two problems. I have used x replaced by lambda x, y replaced by lambda y. For this problem, I have used the second definition for homogeneous function. So that I have used here y power 0 into 2 into x by y, e power x by y minus 1, 2 into e power x by y, f of x comma y. X by y is the y power 0 into f of x by y. So this is a homogeneous differential equation. For this, how to use the substitution? For the previous this one we had put y is equal to Vx. Here put x is equal to Vy. Differentiating y is equal to Vx, we have changed it to x is equal to V into y. Differentiating with respect to x, dx by dy is equal to v into 1 plus y into dv by dy. So differentiating with respect to y, we have to do it. So we get dx by dy, v into differentiation of y is 1 and y into differentiation of v with respect to y is dv by dy. Okay. Now keep this as 2. Using 2 in 1, equation 2 substitute it in 1, we get v plus y into dv by dy is equal to, here for x by y we have to put, for x by y we have to put v, x by y is v, e power v minus 1 divided by 2 into v, 2 into e power v, sorry, 2 into e power v. Now y into dv by dy is equal to 2 into e power v minus 1 divided by 2 into e power v minus v. Let us simplify this. This is equal to 2 into v e power v minus 1 divided minus 2 into v e power v divided by 2 into e power v. Now this becomes y into dv by dy is equal to minus 1 by 2 into e power v. So we have eliminated x here. Now y and v terms are there, separating the variables. So separating the variables, 2 e power v dv is equal to minus dy by y. Integrating, so integrating here, integral 2 into e power v dv is equal to minus integral dy by y plus c1. Now very simple integration, e power v integration is e power v dy by v is log y. Now let us write this. 2 into e power v is the integral minus log y. We can write this as log c. We can write that as log c. So what is v now? V is equal to x by y. 2 into e power x by y is equal to, what is y from this? That is log y. So here you can write this as minus log c by y, minus log c by y. You can write that as log c minus log c by y. So this is a general solution for this. General solution is this. Now we have to take the particular solution. X is equal to 0, y is equal to 1. Put x is equal to 0, y is equal to 1. 2 into e power 0 minus log. So, you can keep this as log y plus c1 itself. Let us calculate that. So, log y is equal to 1. So, 1 plus c1. So, c1 is equal to 2. Now, the particular solution is 2 into e power x by y is equal to minus log y plus 2 minus log y plus 2 minus log y plus 2. Two into e power x by y plus log mod y is equal to 2 is the solution. So, particular solution we have done. So, in this there are 4 steps. First we have to prove that it is a homogeneous differential equation, and then take x is equal to vy, differentiate it and use that in the first equation. Then you will get variable separable method, then integration is there. Afterwards you substitute the initial conditions x is equal to 0, y is equal to 1, and then get the constant value c, and then write the particular solution. Number 4, show that the family of curves for which the slope of the tangent at any point on it is x square plus y square by 2xy is given by the equation. So, answer is also given here. We have to solve and get the answer. Slope of the tangent is dy by dx is equal to x square plus y square by 2xy. Now, we have to prove that it is a homogeneous equation. For that, f of xy is x square plus y square by 2xy. So, if we divide it by x square, we get 1 plus y square by x square by 2 into y by x. So, this is a function of, so you can see x to the power of 0 into f of y by x. So, is a homogeneous function, is a homogeneous function. So, the second definition of homogeneous function I am using it here, x power 0 into f of y by x. So, this is y by x, f of y by x divided by x square, we get this. Now, what is the solution for this? Put y is equal to Vx. So, differentiating with respect to x, what do you get? Dy by dx is equal to v plus x into dv by dx. So, keep this as equation 2, and the given equation is equation 1. So, in the first equation, use second equation in the first equation. So, how to get it? Using 2 in 1, v plus x dv by dx is equal to, you can see here 1 plus v square by x square. So, we can take this as 1 plus v square by 2 into v, 1 plus v square by 2 into v. Now, let us simplify this. X into dv by dx is equal to 1 plus v square by 2v minus v. This is equal to 1 plus v square minus 2v square by 2v, or 1 minus v square by 2v. Now, the equation becomes x into dv by dx is equal to 1 minus v square by 2v. Now we have to separate the variables. You can write here 2v by, I will take this as v square by 1 dx is equal to minus dx by x. On integrating, what is the integration for this? You have to take the denominator as a substitution here. You see, v square minus 1 is equal to t, you have to take, and here it is minus dx by x plus, you can write this as log c, constant as log c. Now, this is log v square minus 1 is equal to minus log x plus log c. So, let us substitute for v square y by x, that is log y square by x square minus 1 plus log x is equal to log c. Now, you can combine these logarithms. How to combine the logarithms? Y square by, this is log of y square minus x square divided by x square into x is equal to log c. So, here we have taken the substitution and we have integrated this. So, here 2v by v square minus 1 we have taken. So, you get log y square minus x square minus x square. So, this is equal to log we can cancel, y square minus x square is equal to into x is equal to c, y square minus x square is equal to c, y square minus x square. Now, or we can write this as x square minus y square is equal to x square minus y square is equal to, this can be taken as this is x is there. So, this is y by x. So, this is cx minus cx, or x square minus y square is equal to c1x is the solution. So, y square minus x square, x cancels, y square minus x square by x, take this s to the other side, log cancels. So, here you get this. So, x square minus y square is equal to minus c you can write it as a constant c1. So, x square minus y square is equal to c1 into x is the solution. Okay. Next we will go to exercise.